everybody get ready, focus, sit up straight, eyes forward. I'm going to introduce one of our teachers, Mrs. Garum, who is going to help start off our event for today.
Thank you, Mrs. O'Donnell. Good morning, fourth grade. Dip, who's behind me, is part of a group of students at the Edison Academy Magnet School that formed a rocketry team called Mach back in 2023. Their aim is to provide students with a platform to pursue rocket science through taking part in a variety of competitions. Dip was invited to submit a proposal for NASA's student launch and will present today with his team about model rocketry in space.
Thank you, Mrs. Garum. So today, good morning, everyone. How are we doing today? As Ms. Garum said, my name is Dip. Next to me is...
my name is Ishan.
My name is Loki.
And my name's Veda.
And together we are Mach Lightspeed. So we'll be starting off with what is rocketry. Now, who's seen a rocket actually fly in space before? Good, so a fair bit of you know what a rocket is. Rocketry, if you look it up in the dictionary, is the study of using and launching rockets. So just on here, you can see a few kinds of rockets. The one on the left and right are actual rockets, and the ones in the middle are logos. So who wants to know how rockets work? All right, let's check it out. The secret behind how rockets fly is they push something. It can be anything. As long as you push something one way, you're going to go the other way. So the rocket engine, what it does is that the engine at the back of the rocket, you see that giant thing, the giant fire coming out the back? It burns a lot of fuel to create really hot gases. And this gas is what you see coming out the back of the rocket, and it's really, really fast. And what that does is it pushes the rocket up, which we call thrust, which is really, really powerful.
So who before has like blown up a balloon like as far as you can go and then let go and seen it fly all over the place? Okay, yeah, most of you've done that, right? Yeah, you too. Okay, so now a rocket is basically like that balloon, except those gases and that force that comes out is really fast. It's really powerful. So it goes a lot faster than your balloon would, and that speed is enough to go to the moon and to Mars and wherever you want to go. So it's similar in principle to what you've done before. It's just even more powerful.
So now we're going to be talking a little bit about our solar system, specifically planets. So before we start, let's do a little pop quiz. Can anyone name some planets that are present in our solar system? We'll go in order. So who thinks they know the first one there? Go ahead.
Mercury?
The first one?
Yeah, Mercury.
Okay, so the first one is Venus, actually. Okay, who knows the second one? We should all know the second one.
Okay, yeah, I hear most of you saying, okay, hold up, 1 second. 1 second, everyone. Okay, whoever said Mercury is the first one, you are correct. For whatever reason, this picture is outdated for... Mercury is the first one. Don't worry. Venus is the second one.
Who knows the second one? We should all know the second one. You want to answer? Yeah.
The second one is Earth.
Yep.
Okay. Hold on. 1 second. Let's clarify this real quick. First planet.
I
that's Earth. Who knows the next one? In the blue? Yeah. Yep. Alright. Who knows this
Sounds
one?
like Mach.
In the green? Yep. Yep. Alright, next one. On the pink.
Huh?
Pink shirt. Yep.
That's me?
No, behind you. Yeah.
Saturn?
Yep. The next one. Yellow in the back. Over there. Yep.
Sure wish I could be one.
Alright, next one. Green. Yep. And last one. Yep. Alright. It's cool.
Alright guys, let's settle down. Let's settle down.
Okay,
Settle down!
okay, so now we're going to be talking about why plants are even important and why we study them. So plants are important because they help us understand life on Earth better. And look at this picture here. You see all these planets, and a lot of scientists around the world study them to better understand life and how we can find life on other planets and how they actually develop. So who here has heard of Thor? Yeah, so Thor, we might not find gods on other planets, but we'll definitely find microorganisms living under ice on moons, like Europa. So yeah, that's the scientific answer to it. And on planets like Mars, we find features like olivines or leopard spots, and they help us understand where microorganisms can actually develop. So in our solar system, there are two types of planets, rocky and gas giants. So rocky planets are made of metals and they form closer to the sun. On the other hand, gas giants form farther from the sun. So those are two types. That's one type of rocky planet, and that's another type of gas planet.
Alright, so this is going to be another question for you guys. Who knows what light speed is? Yeah, in the yellow shirt. Yeah. Exactly, yeah. So light speed, in simplest terms, is how fast light travels in space. And yeah. So even though light speed is super fast, as you can imagine, because let's say you turn on a light bulb in a room, the room illuminates almost instantly, which just shows how fast light is. But since space is also so large, it actually takes 8 minutes for light from the sun to reach the Earth. So if you look up into the sky and look at the sun, which you shouldn't do, but if you do that, what you're seeing is actually 8 minutes old. And in space, since space again is so large, we use light years to measure distance, which is how fast light travels in a 1 year span.
Alright, so now we're going to be going on to a quick activity. So, alright, so let's say for a second that the sun is the size of a dime. Okay, you guys, it's like a coin, right? It's like this big, it's in my hand. Let's say the sun is this big. Slide. So let's think about this. If the sun is like this big, how big do you think the planets are? Yeah. Like, give me like, show me with your hand. How big do you think a planet would be? Okay. Okay, so you're not exactly there. Anyone else want to answer? Okay, kind of getting there. Okay, so if the sun is this big, Well then, your first two planets, let's say Mercury, right? Mercury is that big. It's like a piece of dust. It's like a grain of sand. It's like, you can barely see it. So Sun's this big, Mercury is really tiny.
Because the sun's strong.
And then Venus and, that's not the right picture, but Venus and Earth, that's supposed to be Earth. Venus and Earth are both like grains of sand. They're like slightly bigger than Mercury, but they're all really, really tiny. Like if I put it on this table, you probably would not be able to see it. So, someone in the back, show me how big Mars might be. Yeah. Someone in the back. Yeah. Yeah. Okay. Okay, so we know Mercury is like a grain of sand, Earth and Venus are a grain of sand. How big do you think Mars is going to be? It's on screen, but yeah. Okay, yeah. So it's going to be really small as well. It's going to be another speck of dust. So these are like 4 tiny things. You probably can't even see them. But there's 4 specks of dust on the ground, and those are the 4 planets, right? Now, let's say Jupiter. Jupiter's the size of a cupcake sprinkle. So if you guys ever eat a cupcake, you can grab one of the sprinkles and say, this is how big Jupiter would be compared to the sun, right? So Jupiter's slightly bigger than all the other ones. It's a cupcake sprinkle. Now, Saturn is another cupcake sprinkle, so we're getting slightly bigger now. Yes? You have a question?
But what does Saturn need his rings for?
Sorry, I can't hear you. Yeah, Saturn is one of the planets that has a ring around it. You're right.
Well,
Okay, we'll talk about why it has rings in a minute. Okay, we'll get to you. Okay, and Uranus and Neptune are more grains of sand. Okay, so this is what your solar system kind of looks like. You have the sun, which is the size of a dime. You have your 4 first planets. You have Mercury, Venus, Earth, Mars. Those are all grains of sand. They're really small. You have Jupiter and Saturn, which are slightly bigger at the size of cupcake sprinkles. And then you have Uranus and Neptune, which are again grains of sand. So I think you guys understand they're all really small. Like if I put these objects in front of you, you wouldn't be able to see any of them, right? So let's think about this. So if they're all really small, like basically the size of the tip of your finger, how far apart do you think they are? Okay, I would like 8 volunteers. So let's get to the activity, right? Okay, so you have these really tiny grains of sand, sprinkles, pieces of dust, right? Now, let's try to figure out how far apart would these be if these were the actual sizes, right? Let's imagine you're like a cosmic giant, you're like this really big being, and you're looking down at our solar system. Where would everything be, okay? So, here's a quick table, and you don't need to go too far into this. So, I'll explain this, okay? Let's say this cart, you see this cart over here? Okay, yeah. Okay, let's say this cart is the sun, right? And the sun is like a dime sitting on here. Let's say it's the size of this piece over here. Okay? If that little thing is the sun, Mercury, I need one. Who wants to be Mercury? Alright, you're okay. So Mercury is going to be about half a meter away. So Mercury, come stand here. You're going to be around over here. Right. Yeah. Okay, Mercury is going to be about that far from the sun. And remember, that's a grain of sand. It's really tiny. Okay? Now, Venus, who wants to be Venus? Alright. You are going to come right here. You're going to go, okay, so you see the distance between him? You're going to go double that. Over there. A little further. A little further. Yeah, okay. So, you have the sun here, you have Mercury, and you have Venus. Now, who wants to be Earth? Actually, you're wearing blue, so we'll make you Earth. Okay. So, around 150 centimeters. Do you know how far that would be approximately? Okay, so Earth is going to fall in around there. Okay. Now, Mars. Who wants to be Mars? You're wearing red. It's called the red planet after all. So, okay, so you're going to go the same distance, just over there, over there. Now, who wants to be Jupiter? Rock, paper, scissors. You two. Okay. So you're Jupiter. You sent like 7 meters away. 7 meters. Yeah. You can go out there. A little farther. Yeah. Okay, so Jupiter's gonna be around there. You see where he's standing? So Mercury, Venus, Earth, Mars, Jupiter. Now, who wants to be Saturn? Okay, you're Saturn. So okay, so you see how far he is from here? Go twice that distance. Go all the way to the back. Alright, you guys in. Keep going, keep going, keep going, keep going, keep going, keep going. Keep going, keep going. Okay, stay there, yeah. Okay, so from here, she's around, she should be around 14 meters away. So as you can see, from Jupiter to Saturn, you double the distance, right? So these four were all kind of in the same area. He's a little farther away, and then she's really far away. She's on like on a different scale, right? Now let's say, okay, who wants to be yours? Okay, you would have to go outside this room onto the playground, and you could go sit on the slide. So you're gonna go really far away, okay? And then so we're not actually gonna send you. And then Neptune, which is the last planet we're considering, is going to be probably, do you guys know where the front parking lot is? The first four planets are relatively close to each other. And then Jupiter's a little farther away. Saturn's really far away. And then Uranus and Neptune are like on a different country entirely. They're out in the parking lot, right? So it's kind of an idea of the scale of the solar system. They're not all right next to each other, right? They're like spread apart over a really vast distance. And remember, when he's in the parking lot and he's on the slide, they're the size of like a grain of sand, right? Like you can't even see it from that far. So, okay, let's cover this one last time. Okay, let's say the sun is a coin, right? It's the size of a coin. Okay, your sun is the size of a coin, and these people are all the size of, let's say, cupcake sprinkles, right? So your coin is here. Your first cupcake sprinkle is going to be here. This is Mercury. Then you have Venus, Earth, and Mars. They're all the size of cupcake sprinkles, right? Now, you have Jupiter, which is a slightly bigger cupcake sprinkle, and he's that far away, right? And you have Saturn, which is from the sun, which is around this big, less than the size of my hand, like this big. You're another cupcake sprinkle that's around 14 meters away. Does that make sense? Okay, so as you get, in other words, space is a lot bigger.
You guys can all have a seat. Thank you for volunteering. Can we have a round of applause for our volunteers? Alright guys, thank you. Thank you for the applause for our volunteers. Now we'll be talking about the competitions that we participate in called NASA SLI. So, a couple of competitions that we do throughout the year that you guys will soon be able to do once you're in middle school is called the Team America Rocket Challenge, or ARC. What it is the rocket looks like this, right? And the way to do well in this competition is set this rocket up to a certain height that the people that make the competition tell you, and this rocket has to go up and come down on a parachute. So it comes down on this kind of parachute in also a certain amount of time.
A parachute?
Yes. So, and another interesting thing is that in this part of the rocket, in this front part of the rocket, we actually keep 2 eggs in here. And these eggs travel 800 feet up in the air and back down in under a minute.
And then they could be used to terminate the flight.
Now we'll have Veda over here talk about rockets for schools.
Yep. Yeah.
You have a question?
about the rocket, is it kind of like the same challenge Mark Rober challenged himself to do when he like made the like egg, you know, the egg drop challenge,
yeah.
when he flew the rocket in space, but like for it to come down without getting any damage? Is it like that?
Yeah, you can answer that. It's basically the same stuff.
Wait a
Yeah,
minute.
so it's basically the same concept. Yeah. So same thing that Mark Rober did, just slightly bigger. if you want.
Oh.
Yeah.
Alright, so can I have everyone's attention?
If you mean
Thank
loud.
you. So another competition we do is Rockets for Schools, which happens in Wisconsin. And that's the rocket you see over here and over here. These two really big rockets. And we actually launch them into Lake Michigan, which is a very big lake. So it actually lands in the water, just like actual NASA rockets. And you guys are in middle school. When you guys get to middle school, you guys can actually make these rockets right here. So this is like the first year one you'll do, and this is the second year one you'll do, if you do well in the first year. And yeah, it's a really great competition. You get to build these amazing rockets, and you can actually design payloads, which are like technology that goes inside the rocket up here. And those payloads can do crazy science experiments, they can record data, and they can do a bunch of fun things.
This rocket right here went 3,000 feet, 3,056 feet up in the air and back into Lake Michigan. And this other one right here, this blue one, went 4,500 feet and back down. And what we had inside the rocket measured how high it went, how the weather was up there, and we actually had some bacteria inside our rocket to see what happens to the bacteria when it travels so fast. Both of these rockets traveled above 200 miles an hour. So I think Joe here can talk a little bit more about Centaurs, which is the club that we fly at. It's right down about 30 minutes that's south from here. And you guys can fly your own rockets too. The rockets you fly can range between about this size to all the way up to this size to all the way up to this size. Joe, if you want to talk a little bit more about Centaurs.
Can we get a round of applause for Joe?
Good morning. If you like, if you like to get involved in model rocketry, there is a model rocket club. It's in Belmar, New Jersey. You're more than welcome to come down, and you can watch for free, fly for free. You can join the club if you're interested, and we'd be happy to talk to you more about it. It's a good way to get involved, and when you get older, you can do what Dick and the team have been doing. So, I'll turn it back to you.
Thank you, Joe. And that's it for us for today. Alright, thank you guys for the applause. We're very glad that you liked our presentation.
Yellow shirt. Does the rocket cool shirt what? You wanna?
One of you guys want to stand in the middle and field the questions and make it easier to hear.
So, I believe the question. I'm sorry.
He's asking when the rocket launches, does it burn the planet while the fuel is used?
Okay, this is a good question because it actually does. Okay, so let's think about this for a second. So when the rocket is taking off, you know how it's really hot and all the fumes are flying everywhere? So those fumes, they're not exactly good for the environment. Like, you should not go breathing that. That's not healthy at all. And it's actually a really big concern because as scientists launch more rockets and as we go farther into space exploration, certain organizations are concerned with how much fuel is getting burned and how many gases that are not good for us are getting released into our air, right? Because every rocket that we launch makes it slightly more difficult for the Earth to breathe. It makes it a slightly less balanced place. It makes it slightly more toxic, right? So We're currently developing ways to make this launching process less harmful for everyone. So you guys know how electric cars are becoming a thing now, right? You're going from these gasoline vehicles that burn fuel and create all these harmful gases to electric cars that are better for the environment. So we're doing similar things in rocketry. We're trying to find alternative forms of fuel so that we don't have such a bad impact on the environment. So yes, it's a good question, and yes, it does hurt the environment. We're trying to fix it. All right, one more question. All the way in the back.
Nice one.
Did they actually find life on Mars?
Did they actually find life on Mars?
Okay, so this is a good question. So certain planets for Mars, not yet, is not confirmed. We don't know for sure. However, does anyone know what's on the bottom and top of Mars, on the two sides? Yeah. Yeah, so there's North and South Pole. You know what's on the North and South Pole of Mars? Yeah, but yeah, it's basically ice. Now, ice is, as you know, frozen water, correct? Right. And one of the reasons life can live here on Earth is because there's water. So we think that because there's also water on Mars, it's possible that life can live there. We don't know for sure yet. We haven't found life, but it's very much possible because there is water there. And there are also other planets in the solar system, other bodies in the solar system that could have this. For example, Jupiter has a lot of moons. Did you guys know that? It has it's way more than how many we have here. It's like 14 or something like that, right? So, never mind, 75. Okay, so certain pieces of those moons have water on them, and those are capable of having life. So again, we have to do more discovery and look closer. But yes, it's very much possible that there is life in other areas on our coast.
Okay, we thank Dip and his team of Mach Lightspeed, and we hope you learned something about space and planets. Thank you.